Hello students, these are the topic tests brought to you by Bodhee Prep. The idea of these topic tests is once you've completed the basic concepts of a topic, you can go through these tests to understand your exam readiness for that topic. Acts as a feedback loop as well. With every topic test, there is a video attached. This video gives you the solutions as well as a broad analysis of the attempt and what could have been an exam-like attempt. If you do like the test, there are more than 200 topic tests available on the Bodhee Prep Android app. The link is in the description for the video. Please download that app and make use of these tests. This video specifically is about topic remainders, test number 5. Overall, this test was a moderate level of difficulty test, and any attempt of about 6 to 7 net questions correct would give you a 95 plus percentile if this was the exam. Attempt time here should be somewhere around 20 odd minutes for the simple reason that there are fewer questions where cases were to be formed. And therefore 20-minute attempt time should be good enough. If you look at the questions, what is the remainder when 9 raised to power 83 plus 5 raised to power 32 is divided by 6? Now 9 raised to power 83 can be written as 3 square 83. So this becomes 3 raised to power 166. Any power of 3 when you divide by 6, 3, 9, 27, 81, 243. We see that anything divided by 6 will always give us a remainder of 3. Any power of 3 divided by 3 is the remainder of 3. So the remainder from here will be 3 as well. When we look at 5 raised to power 32, 5 raised to power 32 means 6 minus 1 raised to power 32. So from here, the remainder will be minus 1 raised to power 32, which will be 1. So remainder of 3 from here, 1 from here, and overall remainder of 4 becomes the answer. Again, since there are 2 steps, therefore I am saying moderate, but in any case, attempt time should not be more than 2 minutes. Find the remainder when 21 raised to power 705. 21 raised to power 705 divided by 17 can be written as 17 plus 4 raised to power 705 divided by 17. This further will leave a remainder of 4 raised to power 705 divided by 17. Since you want to square it, eventually we write this as 4 into 4 raised to power 704 divided by 17, which becomes 4 into 4 square, and 704 divided by 2 will be 352. 704. This becomes 4 into 16 raised to power 352 divided by 17. 16 can be written as 17 minus 1, 352, not 325. Because that will change my answer otherwise. 352. So when 4 is divided by 17, the remainder is 4. When 17 minus 1 is divided by 17, the remainder is minus 1 and the power is 352. The overall remainder from here will be 4 into 1, that is 4 becomes the answer. I think this is a straightforward question, just one step involved. 90 seconds, easy question should be done. The remainder when n is divided by 18, n divided by 18 is 16. Given that n is a multiple of 20. So let us look at for a number like this. N divided by 18 should give a remainder of 16, should be a multiple of 28. So if we look at the numbers that satisfy the first condition, n by 18 gives a remainder of 16. The first number will be 16, the second will be 16 plus 18, which will be 34. The next number will be 34 plus 18, 44, 52. The next number will be 52 plus 18. This will go on for a long time. If we write an equation and solve, get a value of x and y. Okay, so this process will go on for a long time, and we might because the next divisor is 28. I am skipping this process. Instead, I'll write an equation. The number n can be written as 18a plus 16. Since it is a multiple of 20, it can be written as 28b as well. Divide the entire thing by 4 by 2. 9a plus 8 is equal to 14b. Now from here we can try to find out the solution for a and b, because 9 and 14 are smaller numbers as compared to the other numbers. 14, 28. So basically a will be 14b minus 8 by 9. 28, 32, 56, At the table of 14. 14, 28, 42, 56. The sum has to be 17. Sum has to be uh, 70. Further numbers 84, 98. Again, this minus 8 is not a multiple of 9. This minus 8 is not a multiple of 9. Minus 8 is 34. Minus 8 is 48. Minus 8 is 62. Minus 8 is 76. Minus 8 is 90. So here we get a answer. So if this is 7 and this is 10, and therefore we can say the number is 18 into 10 plus 16, that is 196. So the values that n can take will be 196, and thereafter LCM of 18 and 28. What is the LCM of 18 and 28? LCM of 18 and 28 will be 9 into 2 into 28 is 7 fours are 7 into 2. So 63. 63 into 4. 63 into 4 will be 252. So the values of n could be 196. 196 plus 252 will be 448. 448 plus 252. 448 plus 252 will be 700. 700 plus 252 will be 952, and so on. How many integers between 0 and 18 inclusive could be the remainder? N by 4 is divided by 18. Now we find out n by 4 for the given n's. 196 divided by 4 will be 49. 448 divided by 4 will be 252 divided by 4 is 63. So if we add 63, 112. Just add 62. So this will be 112. Next we'll have 175. Next we'll have 63 again. 238 and so on. Now if we divide these by 18, 49 divided by 18 will be 36. This will be 13. Now, if we look at 63 divided by 18, 18 threes are 54. Additional 9 will keep getting added. So from here, we'll get a remainder of 4. Here we'll get a remainder of 13 again. Here we'll get a remainder of 4, I'm guessing, and so on. So basically, once a number repeats, those are the numbers that will keep repeating. So we can get two types of remainders, either 4 or 13, and that becomes the answer. So I'm saying this would probably be a number question which is towards a difficult level, and about 3 odd minutes should be good enough to answer this question. M and N are positive integers such that 3m plus 8n, 3m plus 8n gives a remainder of 5 when divided by 17. Mod is the remainder function. Find the remainder. 9m plus 7n is divided by 17. Now, if we multiply this by 3, for example, 3 into 3m plus 8n divided by 17 will give a remainder of 3 into 5, which is 15. This means 3 into or 9m plus 24n when divided by 17 will give a remainder of 15. Now, if we subtract 17n from here, 17n is a remainder, will give a remainder of 0 when divided by 17, because 17n is divisible by 17. So the remainder here will still be 15 because nothing has been removed because of 17n. This will give us 9m plus 24 minus 7, which is 7n, divided by 17 is a remainder of 15, and that becomes the answer. We could have also chosen values and tried to find the answer because, for example, suppose here if we say 17 and 5 is 22. Can we get 22 from here? 8, 16 and 6. So if we put m is equal to 2, n is equal to 2, we will get 3m 6, 8m 16. 22 divided by 17 is a remainder of is a remainder of 5. Now if we put that here, 9 into 2 18 plus 7 into 2 14. 14 and 18 is 32. 32 divided by 17 is the remainder of 15 that we are getting as the answer. So again, I think in terms of concept, a moderate level of concept, but even if you put values, you'll get the answer. So 2 minutes to solve the question. Lisa noticed that her 19th birthday is exactly n days after Julie's 19th birthday. Lisa then computed n to the 9th power and divided by 19. N to the 9th power divided by 19. If r was the remainder, how many possible integers could r be? N could be any number. N days after Julie's 9th birthday. We'll have to put values from 1 to 8. 1 to 18 technically. Hmm. So what we can do here is we can use the Euler quotient. Since 19 is a prime number, the Euler number for 19 will be 19 into 1 minus 1 upon 19, which is 18. We can say that any number which is co-prime with 19, which will be every number because 19 is prime, raised to power 18 divided by 19 gives a remainder of 1. Now we have to find out the remainder when n into 9 is divided by 19. N raised to power 9 into n raised to power 9 divided by 19. To get a product of 1, there are two possibilities. Either both of these numbers are 1 or both of these numbers are minus 1. We'll get the product as 1 here as the remainder. The third case that is possible is when n is 19 itself, in which case the remainder will be 0. And therefore, because 19 will not be co-prime with 19. As long as n is co-prime with 19, n raised to power 9 will either give a remainder of 1 or minus 1. If n is a multiple of 19, the remainder will be 0. So R can take three types of values, minus 1, 0 or 1. And that becomes my answer. In terms of level of difficulty, I'd say a moderate to difficult question because it might not strike you as to how to get that one. And there is a very good chance of 0 missing out as well. So solving time may not be high, but I think conceptually it is a strong question. Find the remainder when 4 raised to power 37 plus 6 raised to power 37 is divided by 25. We can multiply by 4, get the last digit and then divide by 4. I'll do this one step at a time. 4, 6, 36, 216, 1296. This can be written as 2 raised to power 74 divided by 25. 2 raised to power 74 is 2 raised to power 70 into 2 raised to power 4 by 25. 2 raised to power 70 is 2 raised to power 10. 1024 raised to power 7. 2 raised to power 10 I have taken inside into 16 by 25. 2024 is 1024 is 1025 minus 1. The remainder from here 1025 minus 1 raised to power 7 into 16 would be minus 1 into 16, which is minus 16. A remainder of minus 16 means minus 16 plus 25, which is 9. The remainder here is 9. With 6 raised to power 37 divided by 25, what we can do is, if you look at powers of 6, 636, I'm looking for cyclicity. 636, 216, 1296, If you multiply 6, so 30 was 6, 3, so 7, 5, 0, 12, 7, 7, 7, 6. Now this divided by 25 will be a remainder of 1 because the last two digits are 76. Multiple of 25 will have a digit of last two digits of 75. So we can take out 6 raised to power 5s from here. And we can write this as 6 raised to power 5 raised to power 7. 6 5 is 35 into 6 square upon 25. 6 raised to power 5 is 7776 raised to power 7 into 36 by 25. Clearly 7776 by 25 is a remainder of 1. 36 by 25 is a remainder of 11. So the total remainder is 11. From the first term we get a remainder of 9. From the second a remainder of 11. So the total remainder answer will be 20. Again, a moderate level of difficulty question. There are two individual steps. Both should take about 1.5 minutes. Overall attempt time would be around 2 to 2.5 minutes. M is divided by 9. The remainder is 6. So M is nothing but 9A plus 6. N divided by 27. 27B. Remainder is 9. What is the remainder when the product Mn is divided by 27? If you look at Mn will be 9A plus 6 into 27B plus 9. So 9 into 27, 9 into 27 AB plus 9 nines are 81A plus 6 into 27 will be 6 into 27. 81 into 2, 162. 162B plus 9 6 are 54. Now if we divide Mn by 27, as we can see the first term 9 into 27 will be divisible by 27. The second term 81A will be divisible by 27. 162 will be 27 into 6 divisible by 27 plus 54 divisible by 27. Each of the terms is divisible by 27 individually and therefore the entire thing will be divisible by 27. So the remainder will be 0. I think easy question, just multiplying the two terms, 1.5 minutes should be good enough to get the answer. Find the remainder and 5 raised to power 201 is divided by 11. If you look at multiples of 5 which are close to products of 11, 5, 25, 125, 625, 3125. 3125 is 5 plus 1, 6 minus 6. As 1, remainder of 1. So basically 3125 divided by 11. 11 twos are 22 minus 9 to 11 eights are 88 minus 4 5 4s are 44, remainder of 1. So 3124 is divisible by 11. From here we have to take out 5 raised to power 5, 25 6, 5, 25 is 5 raised to power 5. We write this 5 raised to power 200 into 5. This becomes 5 raised to power 5 raised to power 40 into 5. 5 raised to power 5 is 3125 raised to power 40. 3125 by 11 is a remainder of 1. So for the first part we get a remainder of 1. 5 divided by 11 is a remainder of 5. So an overall remainder of 5 becomes the answer. Again, single step questions which you've done by now, enough questions would have been done like this. So even though maybe the level of difficulty is moderate because you want to hit 3125, solving time should not be more than 1.5 minutes. 7 raised to power 6n minus 6 raised to power 6n when n is an integer greater than 0. Now if we look at 6n and we take out the whole numbers from here, 2 into 3n. Now in this case 3n we are not sure, could be even, could be odd. But if you write this as 3 into 2n, we can be sure 2n is even. So first of all, if you look at this, 7 raised to power 6n minus 6 raised to power 6n, because 6n and 7n both are even, we can see that this will be divisible by 7 minus 6 and 7 plus 6. Obviously, it is divisible by 1, it will be divisible by 13 as well. Basically, a raised to power n minus b raised to power n is divisible by a plus b as well as a minus b when n is even. Next, we write this as 7 cube raised to power 2n minus 6 cube raised to power 2n. This becomes 343 raised to power 2n minus 216 raised to power 2n. Again, the powers are even, therefore, this expression will be divisible by 343 plus 216 and 343 minus 216 both. This is nothing but 559 This is nothing but 127. Hence, the number will be divisible by 13, 559, 127. All of the above becomes the answer. If you have practiced remainders, this is a question you would have come across, and therefore, even though the level of difficulty would be moderate for the first timer, but I think 2 minutes should be good enough to answer. Find the smallest positive integer n such that 7n leaves a remainder of 3 when divided by 5. Smallest positive integer, 7n. So let's start putting values. If n is 1, this becomes 7, n is 2, it becomes 14, n is 3, becomes 21, 28, 35, and so on. Since you are going to check with 5, I need 5 numbers. This divided by 5 is the remainder of 2. This divided by 5 is the remainder of 4. 1, 3. So at 28, we get a remainder of 3 when divided by 5. What is the smallest positive integer n? 7 4s are 28. So n will be 4 becomes my answer. Easy question. The only thing is we might key in 28 as the answer, which might create a problem. So if we look at the overall test, as I said, we're looking for about 6 to 7 questions in somewhere around 20 odd minutes. My 6 questions or 7 questions will be 1, 2, 6, 7, 8, 10. Which are these ones? This was a straightforward question, would have attempted this. This again was a very simple question. From here, I think there are chances of missing out cases in the question 3, not an exam question for me. Though question 4 eventually turned out easily and putting numbers was something that could be done. I would not say it is an easy question by any means. This again was a good question, so would have left this in the exam. This was a straightforward question. Repeated concept would have done this. Repeated concept would have done this. Is multiplying two numbers. I have done this earlier and therefore would have attempted it. Again, repeated question in that sense. Ninth, again, was a good question. If you're doing it for the first time, may not be able to attempt it. 10th was a very straightforward question, repeated concept. And therefore, my 7 questions, easy ones will be 1, 2, 6, 7, 8, 10. These are 6 questions. You might add 9 to this because you would have seen similar questions and therefore the attempt becomes 6 to 7 questions.